Charging the batteries in electronic gadgets, whether huge and complex as electric vehicles or small and portable like cell phones, has become common practice. The lithium-ion batteries that are used to power these devices are small, lightweight, and relatively inexpensive to manufacture. Despite this, because they're naturally inflammable, there are concerns regarding their safety and dependability as the need for electricity and grid storage continues to expand. In today's video, we'll discuss the advances in battery technology. There are a large number of startups experimenting with alternative configurations backed by legacy automakers that have made investments in these startups and in battery technology. Stay tuned for that. Welcome back to New Vehicle Media, your go-to channel for EV stock. Quick reminder that subscribing's free and liking the video helps YouTube suggest similar content. Comments are loved and featured in upcoming videos. The solid electrolyte opens up a whole new field of chemical exploration, one that has the potential to increase energy density while simultaneously decreasing reliance on essential minerals such as cobalt. In addition, by eliminating the use of flammable liquid electrolytes, battery design becomes simpler and less confined by present safety regulations and standards. Conventional batteries have a temperature limit of 60 degrees Celsius. The solid-state battery, on the other hand, has removed this temperature constraint, which allows for a more straightforward cooling system. That's one of the factors that prevents faster charging times from being achieved. As a result, the solid-state battery has two distinct advantages. First, in terms of chemistry, and second, in terms of the overall system, which would wind up being simpler, lighter, and less expensive in theory. However, bringing the solid-state battery's potential into reality continues to be difficult. The reason for this is that it requires the design solution of an electrolyte that is both highly stable and highly conducive, allowing the lithium ions to pass easily between electrodes within the battery, as well as the development of novel manufacturing methods to produce the batteries that are suitable for the use of these new materials. Therefore, research labs all over the world are focusing on inventing new chemicals that will serve as both electrodes and electrolytes in future solid-state batteries, which are expected to be widely used. For now, it's necessary to use a liquid or gel to charge and discharge lithium-ion batteries, which is why older batteries may begin to leak as they get older. A new, more secure generation of batteries does not rely on liquids or gels for their operation. Instead, two extremely promising avenues in the quest of next-generation battery tech are the use of solid-state electrolytes rather than liquid electrolytes, as well as the addition of silicon to the anode component to increase the energy density of the battery. These two breakthroughs are combined in a single device thanks to a newly created architecture that makes for a solid-state battery that's safe, long-lasting, and has the ability to store massive amounts of energy. U.S. startup Ionic Materials has already produced a polymer capable of conducting lithium ions at room temperature, one of the building blocks for a solid-state battery whose performance is so promising. Automakers' investment in battery tech. Toyota Motor Corporation is exploring in-house development of solid-state battery cells as part of its long-term strategy. The Japanese maker said early September 2021 that it requires more time to develop the tech for pure electric vehicles. However, it would utilize smaller solid-state batteries in hybrid vehicles for the time being. Toyota created and tested a prototype vehicle powered by solid-state batteries last year, putting it through a variety of tests. According to the company's CEO, testing revealed that these batteries had a higher output than traditional lithium-ion batteries. In addition, Volkswagen, Ford Motor, and Bayerische Motorenwerke (BMW) have invested in solid-state battery startups to assist them in perfecting their tech and making it suitable for mass production. A handful of prominent battery startups have garnered approximately $2 billion in investment from automakers and financial backers, with half of that amount coming to QuantumScape Corp., whose investors include Bill Gates and Volkswagen. The pressure to develop a better battery has increased in recent years, as car makers have placed significant bets on the viability of electric vehicles. Global investment in plug-in vehicles has surged by 40% in the last year. Solid-state engineering is still considered a long-term project. While mass-produced solid-state batteries may be a decade away, automakers are making investments now to gather knowledge and prepare their manufacturing facilities because they don't want to be left behind when everyone else has the technology and they don't. The development of lithium-ion battery tech in the 80s and 90s resulted in the formation of Tesla, the world's first commercially successful electric vehicle manufacturer. Since then, lithium-ion batteries with a liquid electrolyte have improved in terms of the amount of travel time they can provide between charges and have become substantially less expensive than they originally were. However, there are several disadvantages to using lithium-ion batteries. General Motors recently issued a recall for around 142,000 Chevrolet Bolt electric vehicles in order to correct a manufacturing problem that was linked to battery fires. Some automobile makers have been forced to recall electric cars due to fire concerns regarding the battery, and they have advised consumers not to completely charge their vehicles or store them in garages until the issue's been resolved. Solid-state tech, according to industry executives and analysts, would make batteries safer because the core material is less likely to be combustible than conventional tech. Lithium-ion batteries face several challenges, the most significant of which is that as their energy density grows, the likelihood of them catching fire increases. For now, no one has successfully developed solid-state batteries that can be mass-produced and installed in millions of cars. However, companies are optimistic that they will be able to achieve their aim by partnering with vehicle manufacturers who have more than a century of experience in mass production. QuantumScape, a Silicon Valley business, announced that it has made a significant advance by successfully testing batteries with its solid-state technology. According to Volkswagen, its battery specialists independently confirmed QuantumScape's experiments in their own lab and agreed to spend an additional $100 million in the startup, increasing the total amount of money the corporation has invested in the company to $300 million. This is a promising sign, indicating that the battery company is on the verge of achieving success. Furthermore, Volkswagen has committed, in principle, to the construction of a pilot facility to manufacture solid-state batteries suitable for use in electric vehicles using QuantumScape technology. The final decision of the pilot line is still pending, as is a decision by the German government on whether or not to provide financial assistance to the project at hand. The conclusion: when it comes to developing a cheaper, longer-range electric vehicle, automakers are investing more money in solid-state batteries, a technology that has long been considered a moonshot. Lithium-ion batteries are used in the majority of electric vehicles today. These batteries have improved in power and cost over time, but they still have drawbacks. According to auto executives and analysts, the new tech has the potential to deliver faster charging times while also making the battery pack safer by removing the flammable electrolyte solution found in lithium-ion batteries. The technology is still unproven in real-world applications, making it a difficult barrier to cross for the general public for many years to come. Admittedly, solid-state batteries are still prohibitively expensive when compared to current lithium-ion options. Developing novel materials requires cost-competitive manufacturing procedures as well as material benefits over currently available alternatives. I'm curious to know what you think about this. It took a long time for lithium-ion batteries to become economically viable, which opened the door for affordable electric vehicles. Do you believe that solid-state batteries will outperform lithium batteries in terms of cost-effectiveness in the future? Let us know what you think in the comments section below. Big Wedge is displeased with the government's decision to enact legislation that prevents hydrogen-powered automobiles from becoming a viable option. Therefore, he believes that a law should be adopted to prevent the government from controlling technological advancement. That should wrap things up for today. Keep in mind that subscribing is still free and liking helps YouTube recognize your preferences. Thanks for taking the time to watch, and I look forward to seeing you in the next one.